Thanks for downloading a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online. Now stay tuned for your 3CR podcast.
Hello and welcome to Lost in Science. My name is Chris, and along with my erstwhile colleagues, Claire and Stu, I have some fantastic science for you today. One of the things I think you might have noticed that I've been doing a lot lately is picking on physicists who intrude into other fields, complaining about some of the damage they do. Is that right?
Do you think that's allowed because you're a physicist? You're allowed to pick on other physicists?
That's kind of my excuse, but let's face it, anyone can do it, and basically frequently people do it.
I think honestly, in any branch of science, the people who pick most on that branch of science are other people in that branch of science.
Yeah,
totally.
If you look at, that's pretty much how science works. Is go, your paper's wrong, my paper's right, your paper's wrong. Yeah,
that's the only way we get progress.
That's true.
So pick on.
Well, I'm not actually. I'm going to do something different today. I'm going to ask the question: can these intruding physicists, can they do any good? In fact, I'm going to look at a recent paper published about a physicist who has ideas for combating online hate groups. So
I think I read about this guy the other day.
Yeah, it's some pretty cool research. But we're going to see if it stands up and whether there is some good to come out of physics after all.
Or whether physicists just think they can solve everything. Once again.
Maybe.
If hate groups were a perfect sphere with frictionless surface.
And they're in a vacuum. Yes. Claire, what problems are you solving for us today?
Well, we have a guest this week.
Excellent.
It is Dr. Gabriel da Silva. He's a chemical engineer and senior lecturer at the University of Melbourne. And he's going to be talking to us a bit about air quality, air pollution, and where Australia is in terms of our air pollution. It's not all it's cracked up to be. And our standards and, where we actually sort of sit in the world is a little bit behind the World Health Organization standards.
Oh, really?
So the bar that we set isn't the same bar as the rest of the world, which is quite interesting. So, anyway, I'm going to have a bit of a talk to him about that. Australia's
air supply doesn't mean what it did in the 70s.
Thanks, Stu. You saved me from doing a who's on first joke with the World Health Organization. Stu, what have you got for us today?
Well, I was doing some reading and I discovered a weirdly interesting connection between teeth and tongues. And it's not just that they're really close near each other in the mouth, but there's something much more interesting going on.
Oh, my
with
goodness.
teeth and tongues, which I'm going to go into much more detail. It's got to do with fish.
Okay.
How about that?
Gosh.
Will you have some tongue twisters for us to kind of help us out with
Possibly.
this? Okay,
Possibly.
great.
I hope this is going to be about the tongue-eating louse.
No, unfortunately, it's not.
Damn.
Save that for another time.
Okay.
Oh,
great.
I hope it's going to be about the aliens from Alien.
I hope, yeah.
Yeah.
Do they eat your tongue?
They had teeth on their tongues.
Oh, they had a little head that was their tongue. Yeah.
Next to your mouth. Yeah. Did that have a tongue inside it?
It just was a Russian doll of alien heads. Yeah.
Something for everyone to think about. Well, on with the show. Now, why do physicists intrude into other fields? Is it just because they're arrogant to think that they know everything?
Short answer, yes. Long answer, no with a but.
Yeah,
Or
probably.
is it just because you can apply physics theories and concepts to other things?
That is one of the reasons. One of the things that physicists study is, say, complex systems and this sort of stuff. And a lot of the same mathematics works on other complex systems as well. And we are surrounded by all kind of complexity. As a good example, there was a paper published earlier this year about the hipster effect. I don't know if you saw this.
I saw it before. It was cool.
Okay, Mr. Plaid Shirt over there. Now, so yeah, this is actually a mathematician who released this. Jonathan Touboul from Brandeis University in the United States. And basically his work explained why anticonformists all end up looking the same. So, look, the basic idea behind it is pretty simple and almost obvious sounding. So, if the mainstream fashion, say, is to be clean-shaven, then the hipsters will try to rebel against that by growing beards. Now, but the thing is, from a mathematical point of view, trying to model this, the way it works depends on how long it takes for the hipsters to identify the trend. So if it's instantaneous, then as soon as the trend starts to form, people will rebel against it, you get all kind of randomness happening. But if there's a delay, like a long enough delay, then the hipsters will synchronize and they'll all end up looking the same. And this was beautifully illustrated after the paper was published there was a man who complained to MIT who read their online article. They used a photo to accompany it, and he complained to them that they had stolen his photo, and he was offended. Not only them stealing his photo, but then calling him a hipster. Anyway, it turned out that it was a photo of a different model and who basically just looked the same as this guy.
Individuality at work there.
Pretty much. The paper was proven in pretty short order by that. Anyway, this thinking can be applied to something even more dangerous than hipsters.
What could it possibly be?
To use a short word, Nazis. Let's just say that. Okay. No, so the internet today is pretty effective at spreading hate, as we've seen. There's been a lot of mass shootings recently that have been at least internet facilitated or inspired or spread. And there was a paper published just recently in the journal Nature by a complexity theorist, Neil Johnson from George Washington University, to show how online hate, the way it works, is similar to how water boils or how milk curdles.
Okay.
Sounds ridiculous, I know. Okay, so let's think about milk for a second. Now, milk is a mixture of fats, proteins, and sugars all in a liquid, right?
Yeah.
Water.
Yeah, basically, yeah. Now, when milk goes off, when it gets older, it gets more acidic, i.e. sour, and the change to the pH causes the protein molecules in it to start to attract each other. So they start to join together, and they very rapidly form large clumps. And the milk suddenly just will go from just milk to suddenly curdled and lumpy.
So it turns into curds, literally.
Basically, yeah. Now, the other thing, recently I've been doing some physics experiments in the studio. I decided not to do a
milk
live
curdling
experiment, of milk curdling or of online hate.
Well, that's good. That's good.
Yeah.
We don't need that in the studio.
Yes. But it turns out that online hate does work similarly. There was an earlier paper published a couple of years ago where Johnson showed, he looked at the growth of ISIS and showed how it grew very rapidly in a short period of time using the same process as gel forms. So in this new study, what he's done, he and his collaborators have looked at hate networks across sort of worldwide on all the platforms they could, and to find out how the networks work. And what they found was that similar to how you get these clumps of curds in milk, you get the hate networks divided in about 1,000 clusters.
Right.
And 1,000 isn't that many. It might sound like a lot, but you think like a sort of ubiquitous thing. Isn't
like
it about
1,000 people contributing?
Well, the size of the clusters varied, but the average size was about 1,000. So you got basically 1,000 groups with 1,000 people in them each.
Right.
So about 1 million people worldwide who are kind of in this network. So he looked at how they formed, but he also, as a result of this, suggested 4 possible policies to help combat them. Now, these are from the mathematical models. They're not necessarily legally viable or politically viable, but, there are some suggestions that could help.
Like ultra-high temperature treatment?
UHT treatment.
Possibly. Look, I did wonder about this when I first saw this because I thought, so if he's claiming to know how to stop, online hate, does he know how to stop milk curdling or water boiling just by attacking the bubbles?
Pasteurization.
Exactly. Okay, so one of the first idea was to target the smaller groups. So essentially, if you try to tackle the bigger groups on one platform, say you want to kick a group off a platform, what happens is they just basically rejoin and come back in a stronger and more resilient form. So he gave an example of the KKK was kicked off Facebook quite reasonably. They went over to a Russian network called VK and they grew grouped over there. And then they came back to Facebook, except they changed their name using characters from the Russian Cyrillic alphabet that weren't recognized by Facebook's algorithms.
Right.
So they'll be able to sneak back on, hidden from plain sight. So that kind of stuff, yeah. Whereas small groups, on the other hand, they're easy to target and they can be picked off before they grow. So that's the idea there. The second policy was to ban a small, randomly selected number of users. So essentially, if you try to ban all the users in a particular group, you're likely to get a backlash.
Yeah.
But it turns out that if you were to just ban a random selection of about 10% of the users, then you essentially disrupt the networks and the thing falls apart. So it's a smaller scale problem. Again, whether it's legal or not is another question. Another one was to deliberately form your own clusters, like anti-hate clusters, to combat the hate clusters, sort of kind of like an immune system to tackle the clusters. And the fourth one was similar, but it relies on the fact that these different clusters, they've got a lot of similarities to each other, but they're not identical. So, for instance, there are some neo-Nazis who want to unify Europe and some neo-Nazis who want to split up Europe into different countries. So if you introduce another cluster that brings those two together, they'll end up fighting amongst themselves. And
you won't have to do anything.
Essentially, they'll be too busy to worry about anything else.
Great.
So, yeah. Anyway, this is the theory. Whether these ideas actually work in practice is, of course, yet to be established. We physicists like to do theories.
And are the physicists going to be on, like, Facebook's payroll now? Like, where do we go to next?
Who knows who Facebook is paying? I can't comment on that, Claire. No, I don't know. This has just been published. I don't know what the plan is here, whether anyone's going to actually act on this.
May well just be a suggestion at this point.
Yeah, at the very least. You think about the level of disgust you feel for, say, curdled off milk and apply that to online hate groups. It's probably appropriate. If we've learned anything from it, that sounds useful at least.
I'm Maggie Adair Pocock, and you're listening to Lost in Science.
Have you been to a foreign city and thought the air smelled a little different to Australia? Maybe there were fumes of diesel or woody charcoal smells of coal stoves. Or maybe you've been lucky enough to see a sunset abroad but haven't really visualised it because of the smog. With the World Health Organization estimating over 4 million premature deaths from poor air quality worldwide, it's an issue more important than ever. But how is air quality different in Australia? Here to talk us through the facts is Dr. Gabriel da Silva, Senior Lecturer in Chemical Engineering at the University of Melbourne. Gabriel, welcome to Lost in Science.
Hello, thank you for having me.
So, Gabriel, tell us, what does bad air quality really mean?
Well, I guess at the simplest level it means that there are either gases or there are particles in the air that are unhealthy for you. And bad air quality means different things in different places. So there's lots of different things that could be in the air that could hurt your health, and every city has an air quality problem. It's just a fact of living in a big urban area. But what that problem is, or what the biggest problems are, varies from place to place.
So how does, various types of air quality in different cities, how does it affect human health?
There's a whole range of mechanisms, and we're still learning about different things that they can do to our bodies. But the main ones are that they impact our cardiovascular system. So they can contribute to stroke and heart disease. They can contribute to particularly lower respiratory infections, which are particularly dangerous in the elderly population. And with lung cancer, a lot of cases of lung cancer can be attributed back to air pollution. And there are still new things that we're learning about it.
Right. Can you sort of tease out that data and sort of say, okay, well, there's a certain type of air pollution that's responsible for this? Or
Well, we know, so we know the main culprits. So the big one is very fine particulate matter. So we tend to track PM 2.5, which are particles that are smaller than 2.5 micrometers, so much finer than a piece of hair, for instance. So these are formed by a number of different ways, but whatever they are, these very fine particles, you breathe them in, they go deep into your lungs, and then they start to affect your bodies negatively. Another big one is ozone. So, we all know about the ozone layer, and up high in the atmosphere, ozone's great because it filters out UV radiation. But surface level ozone, caused by pollution from cars, coal-fired power stations, attacks your lungs. They're two of the big pollutants that we track.
Right. You mentioned it around the world, but in terms of air quality and air pollution in Australia, how do we stack up?
It's a bit of a mixed scorecard. So I think people associate Australia with, lovely clear blue skies and clean beaches, and we think that we have, we like to think that we have a fairly good environmental quality, and we do in part. So there's a lot of the biggest cities in the world have much worse air pollution problems than us. So particularly in China and India, in places like Hong Kong, Malaysia, they have really significant health problems and big economic problems caused by their low air quality. So we're not quite there, but we do have, particularly in the major cities, days that, there'll be days every year where the air quality gets bad, and for people that have respiratory problems or particularly sensitive to poor air quality, they're really going to find it impacts upon them. And it's estimated, so from government statistics, that about 2,500 deaths per year across Australia could be contributed to air pollution. And this puts it somewhere on par with about the number of fatalities that we see in motor vehicle accidents. So these are both significant problems. And it's maybe, if someone falls victim to one of these diseases that's exacerbated or caused by air pollution, you can't really tie it back to the cause. So it's not quite as visible as some other, major public health issues that we have in the country.
Right. And in terms of how we monitor the air quality, is this, I imagine, Australia's a really big place. It would be quite difficult to get an accurate assessment.
It is, that's true. So the government in each state pushes down to the environmental regulator the responsibility to set up monitoring stations and monitor for the biggest pollutants. So they'll track particle levels, they'll look at ozone, and they'll also look at nitrogen oxides and maybe sulfur oxides, which cause ozone, which contribute to the ozone and the particle pollution problem. But there are two things to consider there. So how extensive is the network of monitoring, and then what are the levels at which they say, okay, this particular pollutant is now too high and we need to do something about it. And there's going to be, so submissions just closed for input into the Australian states' environment ministers reconsidering the levels that we consider pollutants to be harmful. So we have these national air pollution.
So they're sort of like standards or something like that.
Yes. Yeah. And we actually, compared to, so for instance, USA, much of mainland Europe, New Zealand, in Australia we have actually quite lax standards. So in most cases they're worse than what the World Health Organization recommends we should have. And we're hoping that we see, when the environment ministers get together later this year, that we see these thresholds ratcheted up. And hopefully they expand the network of monitoring, so they go, maybe not just into the big cities, but into some of the, particularly on the urban fringes where you have mixed industrial residential zones. They tend to be prone to bad pollution around coal-fired power stations. So the emissions control on Australia's power stations on an international level is abysmal. There is, where a lot of the rest of the world was at in the 70s and 80s. There's just things that we're not controlling for. This impacts, most acutely on those regions. And then we also need a way of enforcing, if there are infringements. So if air quality gets too bad, do we have a mechanism to take action and to go and, clamp down on the biggest polluters that are contributing to that dirty, toxic air?
And in terms of technologies that may be, I guess, being adopted by other countries around the world to improve air quality, do you have any standout sort of innovations? Well,
there's actually, we know where the pollution's coming from. So it's coming from cars, it's coming from burning fuel. And there's actually pretty simple measures to take, which we just need to do it. So the technology to clean the emissions from power stations has been there for a long time. It's easy to do, but it costs money. With cars, there are cars that are more fuel efficient. For instance, don't use diesel, which tends to be a dirtier fuel. There are fuel, we could clean our fuel so that it is less prone to producing emissions. And so there are a number of things that we know what we need to do. We just need to go and do it.
Now, you just wrote a news piece talking about the pollution pods in Melbourne's Treasury Gardens, which is part of Science Gallery's disposable exhibition. Did you get a chance to see it?
Yes, I did. So I went down there Saturday night.
And can you talk us through it?
So the pollution pods is a really great piece of installation art that gives us a chance to kind of walk around the world and experience, but in a kind of safe, recreated way, what it might be to breathe in the air from London or from New Delhi or from Beijing or these other cities that have very acute air quality problems, and they have each their own different air quality problems, just to give us a bit of an idea of what that air might look like, what it might smell like, or even taste like so if you breathe in ozone, you can kind of taste it in your mouth and in your lungs.
Well, Dr. Gabriel da Silva, thank you so much for joining us and talking us through air quality, air pollution, and I guess, in a certain extent, how lucky we are in Australia, but also how we can improve things.
Oh, it's been my pleasure. And absolutely, I think, we are quite lucky here, but we also shouldn't be complacent about air pollution and air quality.
Thanks, Gabriel.
Across Australia on the Community Radio Network, you're listening to Lost in Science. So one of the questions that we had at our Lost in Science trivia a couple of weeks ago was...
that was an excellent night, by the way.
It really was. I had a lot of fun.
Great fun.
What part of the body doesn't regenerate in adults? In the human body?
And the answer is... dee-dee-dee-dee. Chomp, 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 chomp. Teeth.
It is. The answer was teeth. So in humans, we get a set of teeth that once they're mature, or once we're mature, supposed to last us through our entire adult lives. We don't get any more teeth.
No, pretty obvious. Like, you cut off an arm, a new arm will grow back. But if you lose a tooth, you're not going to grow a new tooth. That's science.
Not to that degree, obviously. But you can't regrow any part of your teeth.
Okay, yeah.
You can repair them, but you can't keep them. But a third of people over 65 have none of their own teeth left. That's a very high proportion.
It's a really high proportion.
And teeth are pretty useful, and humans, like most mammals, have teeth made of dentine, which allows us to bite things and chew things and basically make them easier to digest. And
is that what we call enamel? Like we talk about the tooth enamel, is that a different sort of...
Dentine is the same thing, basically. Okay. It's the surface of the tooth. Do other animals have teeth? Yes, obviously. Lots of animals have teeth. Some in quite scary fashion, like crocodiles and sharks. Reptiles and fish most often have teeth. How about birds?
Yeah.
There are fossils.
Do they?
There are fossils of bird-like animals with teeth, but they seem to have disappeared about 100 million years ago.
Didn't they recently do an experiment where they switched off the genes for beaks in birds?
They did some weird things with bird embryos some time ago. Yeah,
and made them grow teeth.
But it might be a good thing that birds don't have teeth. But there are some birds that look like they have teeth. Geese, for example.
Oh, yeah.
If you look at a goose bill, and some of their relatives have tooth-like protrusions...
fangs
inside their beaks, but these are not true teeth.
There's also some great photoshopped photos on the internet of birds with teeth.
Oh, yeah.
Just FYI, everyone.
And then there was Count Duckula.
Yeah, did he have teeth? I think he drank tomato juice, didn't he? So in geese, that's exactly what they are. They're extensions of the beak made of a very hard form of cartilage called tomium, which is also found in turtles and tortoises, which also don't have teeth.
Oh, they're all gummy as well.
Yeah,
aren't they?
they have those beaks.
Beaks.
But this tomium...
For everyone listening at home, Stu just did the best turtle beak face. Love it.
This tomium is really hard. It works fine as a tooth replacement, and it's able to tear up vegetation or even flesh if the snapping creature is so inclined.
Snapping creature?
Well, they're snapping turtles. They're quite dangerous.
I hear ya.
Weirdly, geese also have this tomium cartilage all along the edges of their tongues.
Oh,
so
what?
It looks like they've got teeth sticking out of their tongues, and it's really scary if they chase after you with their mouth open.
Which they do.
They do.
Let's be honest.
They really do.
They
geese are very chasey.
They're very chasey.
Yeah. At least they sound a warning honk.
They just want you to go away. They don't really want to catch you. But teeth growing out of a tongue sounds pretty gruesome, and I searched long and hard for images of teeth growing out of a tongue. I couldn't find any actual pictures, just because I wanted to see if it had ever happened.
All right, okay.
But the main reason I was looking for that was because of some new research from a team of scientists from King's College London and the Georgia Institute of Technology in the United States, looking at fish teeth. So, it seems that tongues and teeth have a lot more in common than just their location, and that possibly some cells commonly found in the tongue could turn into teeth under the right conditions.
No.
Yes. The researchers were looking at the teeth of a kind of fish called a cichlid from Lake Malawi in Africa. And these fish have a second set of teeth halfway down their throat, as they would want to do for whatever reason that they have those second set of teeth. And the secondary teeth are constantly replaced throughout the fish's life. And the researchers discovered that they arise from cells that could also become taste buds.
Oh.
Whoa. Does that mean fish taste with their teeth? Is that what that means?
No, it means that original stem cells can turn into either teeth or taste buds.
Or taste buds.
So when exposed to certain chemicals, the cells form into teeth. And when the chemical, called a BMA ligand, is not present, they develop into taste buds. Great, you might think, for the Lake Malawi cichlids, they can regrow teeth from their own taste buds. Whoop-de-doo. But the research found something even more interesting. The same differentiation may be possible in mammals, as they found chemical markers in the tongue tissue of mice that suggests they may also be sources of cells that could be transformed in the same way. So basically, the researchers think that as taste buds are renewed frequently, they may be able to regrow teeth using a patient's own taste bud stem cells.
Whoa.
But you
to
do it in
regrow.
a dish. You wouldn't do it in their mouth, presumably.
You probably wouldn't do it on their tongue, I would assume.
Yeah.
Unless they want to be more like a duck
Yeah.
or a goose.
But it may be that, it may be possible to actually regrow teeth, and they've never really thought about how that would be possible.
That's
because
cool.
teeth are formed very early on. So it might be that one day we'll have to go out looking for a new trivia question.
And that is it for another episode of Lost in Science. Lost in Science is, of course, recorded at the studios of 3CR in Melbourne, and it airs across Australia with the support of the Community Broadcasting Foundation. Now, we would love you to get in touch with us. We always love to hear from you. You can email us at lostinsci@gmail.com. You can find us on Facebook and send us a message. We are Lost in Science on 3CR. You can also find us on Twitter. You can Lost in Science 1, find us and then DM us or something. I don't know. Or you can find us on your podcast app. If you are able to give us a good rating and review, that would be fantastic, as that helps us kind of lift us up in the algorithms so other people can find us. Or, of course, you can just listen to us on the radio when the same time every week, Stu, Claire and Chris get
Lost in Science!
Thanks for listening to a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online.